guess I'll still wait for some more people coming in. Yeah, thanks a lot. I'll be talking about LLMs, and the intro mentioned, some of you might know me for my work on Spacey. Spacey is an open source library for what we call industrial strength natural language processing. So it was really designed from day one to be used in real products, and we've always put a lot of work into kind of the boring stuff as well, like backwards compatibility, making sure we don't break people's code. And this had a pretty funny or nice side effect more recently, which means ChatGPT is actually pretty good at writing Spacey code, at least for now, until it gets polluted with all the fake Spacey tutorials that some people are creating with AI. But yeah, you can try it out. It works pretty well. And we also built a tool called Prodigy, which is a modern annotation tool and data collection tool for machine learning developers. It was really designed as a developer tool, fully scriptable in Python, and helps you train and evaluate your models. And another thing we're currently working on is bringing basically the power of Spacey and Prodigy into the cloud. Prodigy team's currently in beta. It's been in the works for a long time. And it basically lets you collaborate across your whole team on data development. And actually, a lot of the ideas that I'm talking about today really inspired this product and the workflows we basically want to make more accessible for people. So many of you probably work in industry and develop software in industry, and there are a few general principles that you basically want your software and all the code you write and everything you develop to follow. So one is, of course, your software needs to be modular. You want to have composing building blocks that you can work on, evaluate, test, mix and match individually. And you also want your solution to be transparent. You want to know what's going on, and it should also be explainable. So, even especially if you're working with machine learning, if there's an output, you want to be able to explain and understand what happened and fix problems. Then, in a lot of industries, you also want your solution to be data private. You can't easily send your data to someone else. It needs to stay on-prem, ideally. Well, the development happens in-house. You want your system to be reliable, shouldn't like randomly go down. And it also needs to be affordable, like whatever that means. Maybe you have a budget, maybe you don't have a budget, someone needs to be able to pay for it. So with a lot of the more recent developments in AI and models, there are definitely some problems here. So if you're working with black box models, well, you don't often know what's actually going on. It's not a modular solution. You don't know what's going on under the hood. You can't explain how the model ended up making specific predictions. And if you're using third-party APIs, that's also a problem, because you need to send your data somewhere, or you need to run models in-house, which can easily get very expensive. So how can we solve this and work around it? That's something I'll be talking about today, and I'll show you some solutions for how you can fix this. So also to start, I want to introduce a little practical example to guide through the examples and solutions here. So imagine you're working for maybe a company producing phones and electronics, or an electronics retailer, and this is something you might be tasked with as a developer. Maybe you've already worked on similar problems in your work. And what you want to do here is you have reviews. People write about what they like, what they don't like. And you want to find first mentions of products, and then you want to link them to an internal catalog you have that has all kinds of metadata. And you also want to extract the sentiment for different attributes that you've come up with, like battery, camera, and so on. And that's also often referred to as aspect-oriented sentiment analysis. And then once you have that, you want to add these results to a database and update your catalog. And as you can see, like some of them are actually pretty straightforward. Like the battery life is incredible. Like you barely need machine learning for that. That's easy. But you also have some more vague mentions. Because language, as much as we want language to fit neatly into boxes, it's often just like vaguely gesturing at things. And so here we know what a power bank is, and we know that needing a power bank all the time probably means that the battery life is shit. But it's not really explicit in a text, and it needs a lot of knowledge about the language, but also the general world in order to come to the conclusion that this means bad battery life. And large generative models are actually really good at this. One reason is, well, they're just so large. They've seen a lot of text that includes all kinds of context. And so in-context learning has really been very transformative. And yeah, the models include a lot of information that can be relevant here. And yeah, you probably recognize some of these models, both proprietary APIs and open source models. And now, what if we could just take the part of that model that we're interested in for our review extraction, which is really only a small subset of what the model can do, and take all of that knowledge about the language and the world, and then extract that or distill that into a smaller task-specific model that really only does the one thing that we're interested in. And using transfer learning, we could actually potentially build these specific task networks with relatively few examples and sort of import knowledge from an encoder model like BERT and various variants for different languages, different tasks, different types of embeddings. And if you look at the literature and the research around it, you find that actually even BERT base, which is kind of the most, one of the most basic of these models, is still very competitive when compared to a large generative model for solving specific tasks. And the other thing that's important to note here is that, of course, this is a paper, and the evaluations were done on standard benchmark data sets. That's kind of the whole point and the whole idea. And that also means that we can't control the data. Again, that's also the point of benchmark evaluations. So if that already looks so promising, we can probably get even better if we actually have control over the data, which we have in this case. So if we're looking at a workflow for how can we take a large generative model and make it do a very specific thing, the workflow could look something like this. So we have a text, of course, and then we have a prompt template that produces the prompt together with the text for the specific task we're interested in. We pass that to the model, get a raw output, so human-readable text, and then we have a corresponding parser that basically takes that output and transforms it into structured data, like our categories or extracted spans that we're interested in. So now what we could do is, well, we can take that task output and we can annotate and correct it and create a task-specific data set, which we can then distill into a task-specific model using transfer learning. And there are, of course, also a lot of more technical aspects of the distillation process, just to, how can we make the model smaller? But what I specifically want to focus on today is the human-in-the-loop part of it, which is, even more promising and even more important, in my opinion. And there's obviously a lot of talk about in-context learning and a lot of research coming out. But just because that's kind of what a lot of people are focusing on doesn't mean that transfer learning is somehow outdated or has been replaced. It's simply another tool in our toolbox that we can use, and that can be very promising and a very good solution for what we're trying to do here. And with large generative models and large language models, it's never been easier to create cool prototypes. I think that's like one of the things that really stands out. And if you saw the keynote this morning, you've also heard about how many projects never make it past the prototype stage, and never make it into production. And there are lots of reasons for that, and also some solutions that we can implement in order to solve this. And one of them is you want to standardize your inputs and outputs. So if your prototype takes a nice text that you can put into your demo and outputs the answer as text, that can be very impressive. But if your production system actually needs to process user-generated reviews that you don't have control over and output structured data, that's a mismatch, and that means that your prototype might not actually translate into a useful system. So if you have a workflow for your prototype that actually uses the same inputs and outputs, there's a much higher likelihood that it will also translate into a useful production system. And another thing is that you really want to start with an evaluation. You need a way to tell whether your system is improving. And I know that that's not very exciting, especially if you're just working on your prototype and you're like, oh, I want to move forward, and then taking a step back and creating evaluation data. That might not be the funnest thing, but it's incredibly important. And you also want to have data that really says exactly what the correct answer is. And you need to create that. You can't just, some people might suggest like, oh, just pass it to an LLM and let GPT tell me if it's, if the results are good or not. But that's kind of pointless. That's like training on your, that's like evaluating on your training data. Having a way to tell whether your system is improving and actually doing what it should do is important. And I highly recommend tomorrow, if you're around, checking out my colleague Sophie's talk, where she'll dive a lot deeper into that topic with a lot of examples and, of course, also some tips on how to best approach this. And another point is if you're doing an evaluation and tracking these accuracy scores, that's fine, but you also don't just want to assess the accuracy number and fixate on that. It's also important to understand whether your system is useful and actually solves the problem. And the link below, that's a blog post I wrote where I go a bit deeper into that topic if you're interested in. Just fixating on a number is definitely can be problematic, and you also want to make sure early that your accuracy score actually correlates with your utility, because if not, then you're really in trouble. Another aspect that I've already hinted at is you want to work on your data iteratively. Just like with programming, the first idea you have is probably not the best one. So you want to have a process where you can start over again, try out new ideas until you have something that works. And finally, language, as much as we want it to fit neatly into boxes, it usually doesn't. And there is a lot about the structure and ambiguity of language that's important to understand. And it's something that you can use to your advantage, but it can also really throw a wrench in your nice black and white scheme. And if you work iteratively, you'll actually catch these problems sooner, and not just once you're trying to convert your prototype to a production system and realize that actually language doesn't divide so neatly into my different categories. And now, if we're looking at a possible workflow for how we can build that prototype, this is also something we thought about a lot when building Spacey and thinking of ways to how to integrate large language models into a workflow. Here you have a large generative model that has all kinds of weights and can do all kinds of things. And then what you can do is you can prompt that model and transform the output into structured data, which is something that we've built in Spacey LLM. And what you get out at the end is a structured machine-facing doc object as the output, which includes all the structured data. And it basically, the component abstracts away all the prompt details and really gives you the structured data. And then in production, what you can do is you can distill those individual components and tasks into smaller components that really only do the one thing they're supposed to do. And the output is the same. You have a structured machine-facing doc object that holds all the structured predictions and basically the same input and output as your prototype. And of course, what's important here is having, what I'm talking about is having a human in the loop, and because we don't just want to replicate what a large language model can do. We want to improve it, and as the saying goes, garbage in, garbage out. there is a lot of value in getting the human feedback, especially for those parts where it's most important. So what we can do is we have our large generative model, and of course we want to evaluate it. We want to know what performance do we get out of the box and what are we up against. And also test that against maybe other approaches. Like if a regular expression gets you 99% accuracy, it's fair to wonder, hey, do I actually really need machine learning here? So we have our baseline out of the box of how our model does on this task. And then we can prompt it using all the weights that we have available to solve the specific task and add the specific predictions. And then we can stream that into an interface for the human to review and correct. And what we get out of it are the predictions that are correct and that are really only those parts and those aspects that we're interested in. And then using transfer learning, we can train our task-specific component, and we can evaluate that, of course. And we do this until our distilled model beats and exceeds the baseline. That's the idea. And to relate that back to our practical example, here we have our review again. And this is sort of the data that we want out of it at the end. We want to determine, is it relevant? And then we want to predict what the review includes about the different categories. And I'll be focusing on the aspect-oriented sentiment analysis because that's kind of the more interesting and also slightly more involved part of it. And for now, we're only basically predicting, or we're only extracting Boolean values. Like at some point, you could also have a scale or have like a lot more fine-grained predictions and information. But this is sort of the minimum viable information that you need. And if we're designing a way to really just get the humans' feedback on that those categories. One naive first approach might be, hey, okay, let's just give the human a few checkboxes, pre-populate them, and then let them go through that and review and correct the predictions. But one thing we see here is that this doesn't actually let us capture the null values, because we also have reviews that don't talk about some of these categories. So we iterate, we try out a different approach, and this one seems more promising. Here we actually have categories with positive and negative, and if we don't tick any of the boxes, then we know there's no mention of it. And we can have the large language model that we have in the loop, make the pre-selection, so all the human has to do very quickly go through these examples and correct them if needed. And there's also another approach that we could take, because if you think about it, humans are basically just kind of weird hardware. We have a lot of pros and cons, and one thing we're really bad at is remembering stuff and also performing a series of steps reliably in a row. And so what we want to work around here is basically the cognitive load of the human. So we could also break it down into category-specific questions. So we only focus on the battery life and then ask for the sentiment on it. And this might feel like a lot more work because you're going over your data multiple times for each attribute. But we found that this can actually be much faster instead of slower because the human really gets to focus on one specific category and stays in that mindset and headspace. And in the case studies I'm going to show you, there's also a great example of this where this process ended up being 10 times faster than doing all annotations together. So how does this work in practice? What happens if you actually try this? And one case study is a really nice example of a workshop we did at Pydata New York. And we extracted data from the R cooking subreddit. And we built a system to extract dishes, ingredients, and equipment. And we did that interactively with the workshop participants, which was also a lot of fun. And we used an LLM during annotation, I think GPT-4 or 3.5 at the time. And we were able to collectively beat the few-shot LLM baseline with the task-specific model. And the model we ended up with was only around 400 megabytes, and it runs at 2,000 words per second, or a bit over that, which means it was more than 20 times faster than just using the large generative model for this. And the data development time, that's kind of the cumulative time of how long it would have taken one person to do it. So that's 8 hours. So that's like one person could have done this in 8 hours, and that's like a work day. If you think about like other things you've spent time on, you've probably spent more time on getting your GPU to work or installing CUDA than this. So this is a worthwhile investment. And also, yeah, there's the slides and the video are up, so you can check that out. And there's also a lot of interesting discussion this led to around what are these categories? What is a dish and what is an ingredient? Is Cheetos an ingredient? Well, depends on the context, and you need to make these decisions, and you need to iterate on those, because you know, no AI model can magically solve this for you if you're not even sure about the consistent categories that you're interested in. And then another case study that actually we're hopefully going to publish next week. So you can already bookmark that link. It's not live yet, but it's coming very, very soon. And this project was done by S&P Global, and they're extracting insights about commodities trading, which basically means stuff like crude oil or agricultural products are traded, and that information comes in, and that is live transformed into structured data, so the customers can get that as a structured feed, and the analysts can get that as a structured feed. And obviously, this is a high security environment. I actually got the chance to visit the team yesterday, and kind of saw like they have this secure area where the analysts are working, and no data can leave their servers, because you know, this is information that can really significantly move and affect markets. So it was absolutely crucial that this runs in-house, and it needs to obviously be fast. And they used a large language model during the annotation process to help bootstrap the predictions, and actually managed to achieve a 10x speed up by turning the questions into a more binary format and really focusing on one single category at a time. So I thought that was very impressive. They currently have 8 market pipelines in production, with more to come. And their models are 6 megabytes. So let that sink in. That's like, that's really tiny, and they achieve very high accuracy and run at up to 16,000 words per second, and entirely private and in-house. And here are some more numbers. So the data development time, again, a conservative estimate of 15 hours to create these examples with a model in the loop. So it's absolutely achievable. You don't need like massive annotation teams. This can just be done by you know, very few domain experts. And what's also super exciting is that the project lead of this project, Chris, is actually here. So you can talk to him about the workflow, about what they did, about commodities trading, which I've learned a lot about while writing this case study. So yeah, so that's a cool example. And hopefully next week we'll have the blog post up that has a lot more info on the workflow. So as you could see before, like I talked a lot about iteration, I talked a lot about you know, the workflow, and I think it really helps to think of human-in-the-loop distillation as a refactoring process. So, and just like refactoring software, you basically, what you're doing here is taking a larger business problem and breaking it down into components and solvable tasks. And another thing you usually do when refactoring is, well, you want to reassess your dependencies. Is it worth dragging in this massive library just for using a single function? Oh. Oh, it's nothing. Didn't do anything.
It's coming back.
Oh. Okay. Yeah, reassess dependencies. You know, is it worth dragging in a massive library? Can I just inline that simple function? And similarly, what models are you dragging in? What do you actually need versus, you know, what's just extra baggage that you don't need in your application at runtime? And another thing that people often forget, and that I'll focus on in a second, is you are allowed to make your problem easier. And I mean, it sounds simple and funny, but you know, if you're kind of coming from a research perspective, it's easy to forget that, like, well, you know, if you can change something and that makes the problem easier, that's fine. It's not an interesting research question. Like, hey, I improved accuracy on this benchmark task and you know, achieved state of the art by adding 5 regular expressions. That's like realistic and possible, but that's not an interesting paper. That's why it's not done. But it's totally valid in applied work. And yeah, another thing you want to do is choose the best techniques. There are a lot of techniques available, and you know, they're all parts of the toolbox. You don't you just need to, you know, use what the latest technique isn't necessarily the best technique for everything. And another thing that's really part of the refactoring process is factoring out the business logic and factoring out what is a general task that you can solve with machine learning and what is stuff that's really specific to my problem. And you do the same in a function. Like, you don't write like one massive function that deals with everything and mixes in you know, specific business logic with, I don't know, general opening of files. Like, people probably do this, but like, we've all accepted, hey, that's not you know, good programming. And it's the same when you're building models and AI systems. And I've already mentioned, well, making the problem easier. Also means if your system is less operationally complex, that means that less can go wrong. And yeah, you've probably seen this sort of graph before. Like, when I started programming, I didn't really know very much, so what I built was like pretty simple. Then as I got more experienced, you know, I learned about new things, tried them out, wrote a lot more complex code. Like, maybe you discover classes and then everything's a class, even though it should probably be a function. I also, when I look back at this code, I also didn't really write comments and document it because I felt like it was kind of a sign of weakness. Like, you know, if I solved something difficult, you know, if I add a comment explaining it, I'm basically admitting that it was hard and I didn't, you know, didn't want that. So, which makes it even harder to go through this old code and like figure out what I was thinking there. But then, of course, you know, as I got more experienced, I learned, well, how to use different techniques and what's applicable where, and my code became a lot simpler. And actually, Python is a language that really supports this well and really favors simple solutions if possible. And I think the main reason people sometimes forget that yeah, making the problem easier is an option is that in research, your goal is really to build a commons of knowledge. And you making direct comparisons using standard evaluations, and that also means that you standardize everything that isn't new. And you use the same benchmark data sets in order to test algorithms. Whereas in applied work, you learn from that commons of knowledge that comes out of research. And your evaluation is aligned to your project goals and how useful it is, rather than a number on a benchmark task. And you also just do whatever works. If it works, that's great. And when talking about business logic, what do I mean by factoring out business logic? And one way to break this down is into this little formula where, you know, you apply the classification to your text and then apply the business logic on the result. So in our example here of the reviews, the classification is basically stuff like you know, what products are mentioned, the model of the phone, that it's a phone in the first place, that there's a comparison in it. That's all stuff you predict with machine learning, and that's really a generalizable yeah, classification that can really work on the context, on the logic, and the logic. And on the other hand, you have stuff that's really specific to your task and your business. So you have the reference to the catalog. That's you know, entirely specific to your use case, whether it's the latest model. Yes, you can probably collect a lot of data and try to teach your system that the nebula, space phone nebula is the latest space phone. But that info can be outdated tomorrow, needs an incredible amount of data, and it's not really something you want to predict. It's something that you can ingest from elsewhere, or the fact that it's a touchscreen phone. You would make your problem a lot harder if you were trying to predict this instead of, say, feeding that in from your database, or the fact that it's worse than the iPhone 13. So if you could factor out your business logic, I think that's like one of the actually most important steps of that refactoring process, and actually figuring out what's a task you can predict in a generalizable way and what's specific to you and should be factored out. So yeah, to sum up, I think if we're working with machine learning and with computers, as I said, we love the idea of fitting everything into something we can predict, ideally end to end, and that's also maybe a paradigm that gets new paradigm that sort of gets promoted. All you need is this one model to rule them all, basically. But the reality is that, well, reality does not work that way. And as we've seen, human-in-the-loop distillation is really a refactoring process where you take your problem, break it down, and refactor it. And the result that you get is the cleanest, smallest unit of a system that really solves your task. And iterating on your problem and also using the right tooling that helps you close the gap between prototype and production is really one of the best ways to get past what people call the prototype plateau, or like, it's all part of this post-hype hangover phase that we're currently in. It's, again, it's less about the technology and the models and much more about having the right workflow and iterating on your problem. And again, you're allowed to make things easier, and if your system is less operationally complex, it just means there are fewer avenues for failure, and that again helps going from a prototype to a system that actually works and is transparent, modular, and reliable in practice. And as I said, language is vaguely gesturing at things, and you can't go into a problem and expect that you know all the answers and you know exactly how your problem should be solved and how your data should be divided. You'll almost always have some surprises when you actually start engaging with the problem, which is also why having a human in the loop is incredibly important. And you should have a workflow that allows you to adjust to new things you find out by actually engaging with a problem. And finally, although some people might be telling you that it's like, hey, it's a new paradigm, everything is different now, there's really no need to compromise on the development best practices that we've collected over the years. Because ultimately, AI development is really just software development. And we can apply the same best practices. There's no need to throw away everything that we've had in production for a very long time and build things that are worse than what we've been building. And the same applies for data privacy. You can absolutely build systems that you are fully in control of, and a lot of, and if you think past just, the initial hype and the initial new developments, there are a lot of tools we have in our toolbox that let you take back control and, build systems that are entirely yours and transparent. Thank you.